Alright, so the first line of the job is every 0.2 seconds it acts and saves the generated or tweaked actions, and it saves them, all the motor actions, in the first set, left tab, in the array of sets. So it does action senses, like that. So first it does the actions. So every 0.2 seconds it's going to either generate or tweak them, and then it will output the actions of the generators, act them, and save them. So set in the array of sets. So now the tweak and the generate depends on if it's learned actions or it's just going to generate total random ones. So that's after. So then the second line of the job is to measure x-axis rotation difference between two limbs, then the y, the z, repeat for each limb, ignore the fingers, and you're saving the limb sums and total sum in the sets. So what that means is that when the baby is doing the 0.2 second sets of actions, like 0.2 seconds, 0.2 seconds, 0.2 seconds, 0.2 seconds, 0.2 seconds, and the baby's jiggling around, each one of those is a set. Each motor has its own action, and so every 0.2 seconds they all do one, even if it's a zero or blank, and so that's a set of actions. So it's when it gets acceleration and one of the sets is rewarded by the reward, what's going to happen is that the actions get saved in that set, and the senses come in and save, linking to the actions, and the senses get the reward. So before we get to the rewarding, how that works, the second line in the job is the sense, saving the position of its body. So this is a position of the baby crawling, this is another position, this is another position, this is another position, and so when it's crawling, it has a sequence of a whole bunch of positions that it will be in to do the crawl, and then do it again. So it's got to know when to do the right part of the crawl. So if its hips are here and its hand is there, it's got to do this part of the crawl to keep moving forward. So it's got to know when to do the right part of the crawl. So it's going to know that by the way its body is exactly. If its arm is here and its hip is there, it's going to do this part of the crawl. So as it crawls, every 0.2 seconds, it's got to save its body position with the actions it just did. And the way I came up with to do that was the limb sums and the total sums, so that if its body, even if one's totally out of whack, the others will add up, so that calculating the difference between one limb and another limb, like if like say about 90 degrees difference from this one, that one. So if you add them up for each limb, then if you look at this position and this one, even if one's out of whack, they're similar. So this one and this one is similar. So if you calculate add up all the limb sums, you can kind of make sure that it's similar position and arranged there. Now, it might be a similar position by that total sum, but it might have the value, but it might be a different position where it's different, but it has the same value. So that's why I came up with maybe what might work as limb sums, just the limb sum for this one here, say, the end of my finger, from here to there, my finger, end of it, calculating the difference from here to there, for this, for the x, and it has no y, because it can't go this way, or turn around like this, or z. but you'd add up the 3 axes difference from the rotation for those 2 parts there, and so the limbs would have a smaller the total sum has a smaller range, so the limb sums would have a larger range, so that if it's in this position and you want to recognize that position, the next time it's in that position, it might be in this position, say like in 2 minutes, but let's say it's in this position like this, then that's the total sum of it all added up, that matches, say, to that position. Now each limb, like 1, 2, 3, and then 1, 2, 3, wait. So the total sum matches, and then with each part, 1, 2, 3 in my finger there, those 3, if every single one, 1, 2, 3, 5 of my fingers here times 3, 1, 2, 3 say, every one of those parts of the limb has to be in the smaller, the larger range. They all have a larger range, so that this position, if it's similar to this one, it's in this one now 2 minutes later, say, it matches to the total sum, and then the limb sum, it's going to be this, remember this position I said, if it's in this one now 2 minutes later, it will recognize the same, say, kinda, it'll recognize the same, because here, let's use this one, like that. Here, it was like this, and then here, this is similar. If it was like this, see how like it's like a knee bent? That would be out of range, say. So they all have to be in a range where it's enough. You get what I'm saying? So that's that. I hope you understand that. And then line 3 is I'm gonna have to cut this video.